By the way, Lindsay Ream heard Anna Anderson talk trash to her on YouTube Nation last night. She's a little upset. Yep. I don't blame her. Okay, here we go. All right, so this does not have anything to do. This does not have anything to do with a standard from your book. You don't have, homework problems like this from your book. Why are we doing them? Because it will help you refine a skill that will help you do word problems. They'll be on your test and on your study guide. So it says C is directly west of A. A is 110 degrees. B is 28 degrees. C is 42 degrees. So what I will literally have people do is they will make a compass, which is fine, and they will make that compass like so. We'll go 0 degrees, 90 degrees, 180 degrees, 270 degrees, and they will draw it at each spot, or what? Oh. I guess you want one. Kaylee, you're gone tonight. You're not coming to track, are you? You're at this band thing, aren't you? Oh, all right. Well, you're dressed up. It seems like you probably wouldn't be at track. All right, very good. Okay, so now you can take this. Okay, I can take it. Some people actually cut a shape out and they move it. Did you do this last year, Kelly? Did you cut a compass out and place it at the spot? You didn't. Okay, some people did. Kelly did not. All right, here's what you do. It says find the bearing of A to B. All right, find the bearing of B to A, B to C, C to B, A to C, C to A. You don't necessarily have to start at one spot, but there's a spot I encourage you to start, and we're going to start at C, partly because it says C is directly west of A. And I'm going to draw some dotted lines in here, and these are going to be helpful for you to draw. You can go ahead and sketch these in. Again, you guys want one way to do everything. That's normal. It's not one way to do this. Can't just, you got to kind of intuitively figure it out. So when in doubt, I try to sketch some grid lines, some north, south, east, west lines, stuff like that. Now, if you could just place yourself at the point and think of what your bearing is, you're going to do better. So if I place myself at point C, what degree measure, what direction, what bearing should I walk to get from C to A? East, which is 90 degrees. Does everybody see that? Walk from C to A, I go 90 degrees. Now that I'm at C, I'm going to now go from C to B. Okay? I'm going to finish up. So I'm sitting at point C. So I'm going to try to do all the C's to whatever. So I got C to A, I got C to B. Now, this is 42 degrees, which makes this angle right here what? 48 degrees. Now, think about this. I want to know the angle measure. If I'm going to walk from C to B, it's going to be somewhere between 0 and 90. Somewhere between 0 and 90. You could either say you're 48 degrees past 0 or you're 42 degrees back of 90. Either way, it brings you to what degree measure? 48 degrees. If you're going to walk from C to B, you should travel at a 48 degree bearing. Any questions how I got that? If you take 0 plus 48, you get 48. If you take 90 minus 42, you get 48. Either way, you're going to get 48. Okay. Now, would you like to move to B or to A? Doesn't matter to me. Okay, we move to B. Whoop. Probably. Now I place it right here. Oh, did you say B? Okay. Okay. I'm up at B. and I want to walk to A. The bearing's going to be between what two degree measures? 180 and 270, right? Now, since I drew this triangle, I should fill in some spots. If this is 110, well, this has to be 70, right? So see why I sketched these spots in here? Just some imaginary triangles. And then this would be 20 right there, because that triangle has to add 180. Right? So if I'm going to walk from B to A, I'm going to be 20 degrees past what? 20 degrees past 180. What's 20 degrees past 180? 200. So I'm going to go from B to A is 200 degrees. That's my bearing. Okay, now I'm going to go from B to C. Well, B to C is going to be between 270 and 180. Right, going to be between 270 and 180. 20 and 28 past 180. What's good? 228. So A to, or B to C is 228. Good. All right, now we got to move to A. There we go. Okay, I'm going to walk from A to C. What's A to C? 270. That should be pretty clear. And now I'm going to walk from A to B. Good, 20. How'd you get that? 70 and 20 is 90. So, you know, I know that this makes a right angle. Okay, and I got 70 there, so I should have 20 more there. So 20 past 0 or 70 back from 90. Either way, it's a 20-degree bearing. So if you think about putting your, you know, some people have to draw this because they just don't visualize it very well. Some people actually made a little card and they cut it out and they moved it on their space. Whatever you want to do is fine. Some people can just visualize it, and that's great. Good for you. Now, are you ready for it to all come to a connection here? Okay. All right. I'm standing at point A. I'm going to walk towards the door, which is point B. All right. Here I'm walking. My arm is pointing this way, right? I'm going to turn and face now point A. How many degrees did my arm turn? 180. My bearing is exactly 180 degrees difference, right? Look, A to B, B to A. What do they differ by? 180. B, C, C to B. A to C, C to A. So when you reverse direction, it should always differ by exactly 180. So some people say, well, you just have to figure out one, then flip it around. Yeah, exactly. You just figure out one, then add 180 or subtract 180. That'll be fine. Like, well, why aren't you supposed to do that? Well, because, you know, you got to be able to think through the problem. You know, that's the harder part. Now, these are all standard measurements. Okay, these are all what we call kind of standard bearings. But we want to also think about navigational bearings. So we're going to convert these to navigational bearings. Okay? So, if I'm traveling from A to B, describe to me in terms of north, east, south, and west, what direction I travel. North, east. Now, we have to describe how many degrees east of north we would go. Okay, so starting from north, look at my compass again. All right, look at my compass. From north, you always start at north. How many degrees do I turn to the east? 20. So it's north, 20 degrees east. Let's switch it around. Let's do B to A. Oh, don't do that. If I go to B to A, describe it. South, west. So From south, how many degrees do I turn west? 20. Look, these are the same, right? One is northeast, the other is southwest, 180 degrees opposite direction. Got it? Okay, so now we go from B to C. Okay, B to C. How many degrees did we turn? So from south, how many degrees did we turn west? 48 degrees west. C to B, I'm standing at C, and I want to go to B. That's in which direction? The northeast. How many degrees do we turn to the 48 degrees east? As you notice, it's the same as the above. 270 is just straight west, and 90 is just straight east. So those are navigational bearings. These are standard bearings. You can do it. You're super smart. This is C is directly south. A is 70. B is 60. C is 50. I'd encourage you to draw this on here. Make a little sketch, 90 degrees, 90 degrees. Go to work, figure it out. I'll come and help you. Try this. Okay. All right, so let's see how we got this stuff. Okay. We'll erase those. Okay, so I filled in the triangles. You guys can see, just using basic geometry principles, we should be able to identify that these are, triangles got to add 180, yada, yada, yada. There you go. Okay, so which point do you want to start at? You pick. A. So I move my triangle up here. My compass up here, excuse me. So my bearing has to be between what 2 degrees? 90 and 180. Okay, how many degrees past 90 am I? 20. So that brings us 110. Or if you said, well, I want to go from the 180, that'll be fine. How many degrees back of 180 are you? So, right, if you go back, you got to subtract. Yeah, so 70 back of 180 would be 110. Either way, you get to 110. Okay, now let's just convert it here. That would be southeast, correct? No, can't do that. I always got to go north or south. I always got to start north and south. So the first one is south. So how many degrees am I back of south? 70. All right, B to A. Whoop, we're at A. We should do A to C. A to C is straight south, or 180 degrees, which is south. Good. We got 2 of them. Which point would you like to move to? You choose. Okay, we're going to B. Here I am. Okay. My bearing from B to C, we'll do B to C, should be between 180 and 270. As you can see, I'm 50 degrees past 180. So I add that on, and I get 230. So B to C is 230. What direction is that? South? West. How many degrees west of that south line are you? 50 degrees west of south. So that's the way you write it. South, 50 degrees west. Okay. Now let's go from B to A. B to A is which direction? North, west. Look, opposite of the other one. The one right above it is southeast. This one's northwest. How many degrees west of north are you? Yep, 70 degrees, which is the same as that. C to B. Now I got to move over to C. All right, my bearing should be between what 2 degrees? 0 and 90. Okay, how many degrees past 0 are you? 50. Or how many degrees back of 90 are you? 40. Either way, you come up with 50 degrees for C to B. What direction is that? North, east, opposite the one above, 50 degrees. You should be able to interpret them. I'll allow either one on the test, whichever one you prefer. What B to A? What did we say there? B to A was, we didn't, 290. Sorry. Okay, and then C to A is straight north, so that's 0 degrees or 360 degrees, or you could write straight north. The point is that you have to be able to understand and interpret the navigational ones for the next problems that we do. Okay? So there's a couple problems on your assignment or on your study guide that you can practice like that. Question, Danny. 290. So if I got my compass right here, okay, 0 degrees straight up is 0 or 360 degrees, correct? And I'm 70 degrees back of 360, which is 290. Okay. All right. And remember, you can check your answers. These are off by 180, 180, 180. So a difference of 180. Okay. All right. So this problem is going to look really difficult, but it's really not that bad. 2 ships leave a port at noon. Ship A is traveling at a bearing of north 32 degrees west at a speed of 5 miles an hour. Ship B is traveling at a bearing of south 75 degrees east at a speed of 4 miles an hour. How far apart are they at 4 p.m.? Oh boy. We can do it because we are super smart. Make my quadrant. Okay, this is north. This is east. This is south. This is west. Ship A is traveling at a bearing of north 32 degrees west. You tell me. I need a volunteer. Who's going to volunteer? Very good. Anna Anderson, you tell me. So north, you tell me when I'm 32 degrees west. Right about there? Great. We'll draw it right there. Excellent. So I could label this spot right here 32 degrees, right? And I could call this point right here A. Ship A has traveled there. All right, the other one, ship B is traveling bearing south 75 degrees east. So I start with south. Need another volunteer. Riz, you tell me when I'm 75 degrees to the east of south. I would say this would be about 45 degrees east of south. Good. So this angle right here would be 75 degrees. And that puts us at point B. What does that make this small angle right there? 15. What is this angle right here? 90. The question is, how far apart are they after noon? How long have they been traveling at noon? I'm sorry, at 4 o'clock. They left at noon. It's now 4 o'clock. They've been traveling for a total of 4 hours. If ship A is traveling at 5 miles an hour, how many miles has it traveled after 4 hours? All right, so we have 5 miles per hour times those 4 hours will give you 20 miles. So this length of this segment is 20. The length of this segment here, 4 miles per hour times 4 hours gives you 16. And our question is, how far apart are they at that time? What shape does it make? A triangle. Who said? Somebody almost saw it. Side angle side, which means law of cosines. Very good. So this is 20 here. This is 16 here. And the interior angle, if we add up 32, 90, and 15, we get 137 degrees. And we want to find how far apart they are from A to B. And in order to find out that distance, I can use the law of cosines. And the law of cosines says that d squared is equal to 16 squared plus 20 squared minus 2 times 16 times 20 times the cosine of 137 degrees. We've established that, correct? Using side angle side, we can plug that in, and we can now calculate the distance that they are apart. You want to have a calculator race? Race, set, go. Turn it on. Yeah! No! 33.52. Boom! Gotcha. All right. All right, 33.53. Got it. Got to square root it. All right. Any questions? No, you're done. You just want to know just the part that they are. So, law of cosine is pretty easy to use, right? Setting up the problem, more difficult. Do you understand the bearings? You get the distance. Multiply the time by the speed. Okay, let's try one more problem. Plane. Just a little. All right, fine. Let's take a break now to recognize our sponsor. A sponsor for this afternoon is the Moose Lodge, who will be serving a dinner Friday night. All proceeds will go to the track team. Girls and boys track. I encourage you, raise your hand if you don't have anything going on Friday night. You'd like to go grab a burger for $7 at Moose Lodge. Yeah, the two of us. Who else? Who's going to join me and Anna Anderson? Come on. Oh. You guys are ridiculous. All right. What? Yeah, I'm going to help. Probably 6 to 8. Oh, yeah. All right. A plane flies 300 miles at bearing northeast. Looks like I need northeast type thing. All right. So, we got north and east. Because we're not going to go any other direction but northeast. We're going to switch this. Instead of 70 degrees, we're going to make it 20, okay? 20. Yeah. Okay. Oh, I'm sorry. For the other class, I made it 30. If they watch the video, they'll want to be consistent. We'll make it 30. Hey, don't do that. 30 degrees. All right. Plane flies 300 miles at a bearing of north, 80 degrees east. Very good. 10 degrees away from east. So as I draw this, would you agree that this is about 10 degrees away from east? Okay. Now for this one, I'm just going to tag the end of it and call it 80 degrees. But that's an 80 degree bearing. Is that okay? All right. Now somewhere along that line, after traveling a total of 300 miles, I stop and I turn and fly 400 miles at a bearing of north 30 degrees east. So you tell me when I'm approximately 30 degrees east of north. That's straight north, right? All right. So that's 30 degrees. This distance is 400. And we want to know how far the plane is from its original position. Okay. So what I need to do is I need to figure out, I'm given 300 and 400. I would need an angle to be able to figure out that opposite side, right? So this is the key to make this problem work. Once you see this, you see everything. If I was at 80 degrees and I turned to go 30 degrees, how many degrees did I turn? 50. So what does the supplementary angle have to be? 130 degrees. Now you can what? Well, cosines. That's the bearing. So that was my new bearing. So now we'll set that up. Okay? So if we want to figure out that distance there, distance squared is equal to 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of 130 degrees. Has anybody started on their calculator? Hold on. On your mark, get set, go. Well, mine won't even turn on. No, we're done. No, forget that. That doesn't count. Yeah, whatever. This is stupid. I hate this game. Yes, it's 635. All right, D equals 635.2. 82 miles. Whatever. First time for everything. All right. So you see the trick there? This is the trick, isn't it? Once you figure that out, then the rest is easy. So look at your study guide. Okay, take out your study guide. Test on Friday, test day Friday. You get to use this on your test. See this? Okay, let's look over the test together, or the study guide together. Okay, the top part says solve the following right triangle. Okay? As it says solve the following right triangle, if it's the right triangle, true or false, you can use the Pythagorean theorem. True. And furthermore, if you have a right triangle, do you have to use the law of sines or the law of cosines? No. You can, but you sure don't have to. You could just use like, remember, so you could use SOHCAHTOA, right? You could just say, well, sine of theta, say 35 degrees, is equal to, the x over 9 or something like that. You could go ahead and just set stuff up like that if you have a 90-degree triangle. Okay. Yeah. Part 2 says solve for the following parts of the triangle using the law of sines. So you just need to find A and you just need to find C. That's it. Got it? You don't have to solve the whole triangle. Okay, part 3. You just need to find side A and angle, or side B and angle A. You don't have to solve for the whole triangle. Got it? I don't want to create extra work for you. Flip it over. Okay, for problem 4, what? Yeah. That's fine. Problem 4, it says solve the following triangles. So I give you 6 problems. There you have to solve the entire triangles. Most of them will just have one solution. But you're probably going to have 1 or 2 that have 2 solutions. You probably have 1 or 2 that have no solution. So please keep that in mind. That's why you use your decision tree. That's why Mr. Gantz made this for you. Follow it. You're welcome. All right. 5. Bearing problems, just like we did, right? 6 is kind of tough. All right, 7 is an area problem like you did yesterday. 8 and 9 are just like the examples we did today. You're golden, people. Golden. I'm going to sell you. Make some money. Good luck.